when I started Fastech, my passion and dream was to really create a new end-to-end solution where we used additive manufacturing technology rather than more conventional technologies to make parts with a lot less waste. I come from a background of machining, and when you machine a lot of material away, and there's a huge amount of waste. When I started looking at additive manufacturing technologies, I saw that we could take components with huge amounts of material and reduce them down to what could be a massive saving in waste. At Fastech, we offer a manufacturing solution end-to-end. And what does that mean? That means that we start with our customers, typically a model of the component. We'll use additive manufacturing technologies to print the part. We use 5-axis machines to then machine the part, and we use metrology technology to then offer an end-to-end service from A to Z.
Using our additive technologies, we use both WAAM, Wire Arc Additive Manufacturing, and Laser Wire DED, powered by our Meltio engine. We can produce parts from multiple materials, starting with stainless steels, carbon steels, high-grade alloys like inconels, titaniums, Haynes products. We can produce parts from the size of your fist up to 3,000 kilograms or 6,000 pounds in weight.
I'm standing right next to one of our metal AM systems, Fastech ARC 605 system. In this system, WAAM technology is used to print small to medium to large scale components. WAAM stands for Wire Arc Additive Manufacturing. In this process, arc is used as the heat source and a conventional welding wire is used as the feedstock. Using arc, a melt pool is created on an already existing substrate or an already existing surface to create a melt pool, and then the welding wire is fed into it vertically down to create weld beads. So these weld beads are stacked onto each other, and then layers are formed to ultimately print large-scale components. One of our new metal additive systems, which is called as AMRCP. AMRCP stands for Additive Manufacturing Robot Cell Portable. In this process, lasers are used as the heat source, while a conventional welding wire is used as the feedstock. This system is capable of printing complex geometries in both 3-axis and 5-axis. We added a rotary table that gives 2 more degrees of freedom in the form of rotation and tilt, so that difficult geometries can also be printed seamlessly.
So what we need from our customers is just that one chance to take their digital model, turning it into a component with a manufacturing end-to-end solution that's going to save them time, going to save them costs, going to improve their lead times. Why don't you just ask us?